Do you know common drain amplifier is also known as a source follower? Hi, I am Sukhad Tyagi from KIET group of institution. Currently I am doing a course in ASIC from Pine Training Academy. One of the project which I have worked on is common drain amplifier. Now let me show you this on the Cadence Virtuoso. This is the circuit of common drain on Virtuoso. Here the input is applied between gate and drain terminal and we are taking output between source and drain terminal like this. Here we are taking the output and this is our input. Now we are going to do first DC analysis to set the operating point of the MOSFET. Now I am going towards launch and opening the ADL window. After that we go for DC analysis and save DC operating point and select the component. Now I am going to select the component on the circuit. Here I am taking the component as a parameter VDC, which is applied at the gate terminal. After that I am setting sweep range, which is I am taking from 0 to 1.2. Now I am going to take the input and output which I want to show on the terminal. I am getting the graph. Now from here we have to set the sum of the VGS voltage. Now let I take approximately 600 microvolt at which I am getting approximately 7 microampere current. Now I go for AC analysis. Now this AC analysis start from 0 and up to 10 gigahertz, so that I can see our output is following the input. Here the common drain is also known as the source follower because the output voltage is going to follow the input voltage. Now I am going to see this on the analysis. Here this green one showing our input voltage and this red one showing our output voltage. Here we are seeing that our input voltage is 10 millivolt and our output voltage is also following the input, like it is tending toward 10 millivolt. So that's why it is also known as a source follower. Now if I want to calculate the gain, then I will send these input and output voltage to the calculator, and then by calculation we will find the ratio of V out by V in so that we can calculate the gain. Now I will send this input voltage to the calculator. We know the gain is the ratio of V out by V in. So I have to send also V out on calculator. Here I am getting the gain approximately equal to 1. So means the voltage which we are applying at the input we are getting at the output. Now I am going to calculate the input impedance, which is very high. The advantage of this is that if the input impedance is high, it will take very less input current in it and save lot of valuable power. Now I am going to calculate the input impedance, which comes in term of mega ohm. For this we have to select input voltage and the current which is flowing through this terminal. Now we know that the input impedance is the ratio of input voltage and the input current. So I have to send this voltage and current to the calculator. Then I am going to get the input impedance. This is the value of the input impedance, which is in the term of mega ohm, which is very high. Now I am going to calculate the output impedance. For this I want output voltage and the output current, means the current which is I am getting at the source terminal of this NMOS. Now I go toward ADL window and from there first of all I will select AC analysis and enter the sweep range, which is I am taking from 1 to 100 gigahertz. After that I am going to select the output voltage and the output current from design. Now I will run this simulation. Now I want to send these output voltage and output current to our calculator so that I can calculate the R out. First of all I send this R out to the calculator because the resistance is the ratio of V and I. I am getting this R out, which is approximately equals to 10 kilo ohm. Now this is my overall analysis. If you have any suggestion, please let me know in comment section. Thank you.